Hello, this is Julie Ray, and we are looking at more mathematical formulas today. We have gone over formulas about um, area and perimeter and volume. And now we're going to look at some other formulas that are often used in algebra. These are the ones we're going to be talking about today. We have simple interest, and that is and talking about either when you have money in the bank and the bank is giving you, is paying you to keep your money there, or when you've taken out a loan and you are going to pay the bank or the loaner some money for lending you the original money. Another formula we're going to look at is the distance formula, which says that if you know the rate at which you are traveling and the length of time you are traveling, then you can find the distance that you are traveling. So distance equals rate times time. That's a very important one. And then finally, we're going to be talking about total cost. And the total cost that you spend on something depends on the number of units and the price per unit, which is something that you don't even need a formula for. You do that in your head many times when you're in the grocery store. We're going to look at it in a little bit different way too. So let's go forward. So let's look at this simple interest problem. And let me just say that most of the time, interest is a little bit more complex than this. But this particular problem is about simple interest. And when I look through GED questions, this is the one that came up. So this is the formula that we're using. Also, that is the formula that came from the GED test itself. So remember when you're taking the test, that if you're not sure you remember which formula to use, they give you a formula sheet. So make sure that you go back and check. So let's see, how would we start? You borrow $6,000 at 5% for a car loan for 3 years. How much interest will you pay? Remember that the formula that you use is interest equals principal, which is the starting amount, times the rate, times the time. So the formula for interest is interest, that's the I, equals the principal, which is the starting amount, times the rate, which you can think of as you're paying at a rate of 5%. So 5% is your rate. And then the time, how long do you have to pay this loan back? So remember that the first step is we write down the formula and then we substitute in values. So what do we know? The question asks us how much interest. So that's our unknown. So we leave that variable there. That's what we're trying to find. The principal, or the starting amount in this problem, is $6,000. So we write 6,000 here, substitute that in for the principal. The rate is 5%, and we know that 5% is the same as the fraction 5/100. 5/100 is written in decimal format as decimal point 0.05. That means 5 is in the hundredths place. That's how we write 5% in decimal form. And then the time is 3 years. Okay. We substitute in our known values, and then we solve. If you do that multiplication, 6,000 times 500 times 3, the answer is $900. So that's a very simple interest problem. Remember, the steps are, you have to know what formula you're going to use. You don't remember, make sure you check the formula sheet. You substitute in what you know, and then you solve. So here's a different formula. How far will I travel if I drive 65 miles an hour for 3 hours? So what formula are we going to use? It's asking how far. That's a distance. So we'll be using the distance formula. The distance formula is distance equals rate times time. We substitute in our known values. It's asking me for distance, so I don't know that. Do I know the rate? 65 miles an hour. That is a rate right there. 65 miles an hour or 65 miles per hour. If you see per, that's an indication that that's a rate as well. And then time gives us 3 hours. So when we substitute in our known values, distance equals 65 over 1 times 3 over 1. Now, why did I write it like that? Well, our rate in this case is 65 miles for 1 hour, an hour, or 1 hour. But sometimes we have a rate that is not just 1. So I wanted to show you that that rate is really a fraction, 65 over 1. In this case, that simplifies to 65. So we could have written this as 65 times 3. And I wrote this 3 over 1 as a fraction just to remind us how do we multiply fractions. And remember that we multiply numerator times numerator, denominator times denominator. So in this case, the denominator 1 times 1 is 1. So if we divide anything by 1, we'll get the same answer. So it's not critical that we write it this way, but I wanted to introduce that idea so that you understand that a rate is a fraction. And if the denominator is 1, of course you don't need to write it this way, but that just reminds us what it is that we are actually substituting in. So a rate is a ratio or a fraction, and in this case, over 1 is not going to give us anything else to do, because we know that anything divided by 1 is that number itself. So now we just solve, and we got distance equals 195 over 1. 65 times 3 is 95. 1 times 1 is 1. And then when we simplify this answer, 195 over 1, we will get 195. And what unit were we using? Miles. So it was asking us for the distance. What makes sense that our answer is in miles. And the reason that that actually works is that we have 65 miles divided by 1 hour and 3 hours here. So this hours divided by hours equals 1. That unit rate divided by itself equals 1, and that leaves us with miles right here. where that miles comes from. But you can also intuit that because it's asking how far. So you know that your answer will be in a unit of distance, and miles is a unit of distance, which is used in this problem. Let's look at a different way that happens could go. How far will I travel if I drive 65 miles every 2 hours and I drive for 3 hours? So remember that idea that our rate is not always divided by 1. Here we're saying our rate is 65 miles every 2 hours, not every 1 hour. So let's see. Remembering that our formula is distance equals rate times time, let's substitute in what we know. How far, so we know our distance is going to remain a variable. Our rate is 65 miles for every 2 hours. And that's going to be 65 divided by 2. And then my time is 3 hours. So this is just like the other problem. The only thing that has changed is that our rate is for every 2 hours. So now we're remembering, how do we multiply fractions? 65 times 3, numerator times numerator, denominator times denominator, 2 times 1. So our answer is 195 over 2. Remember, this fraction bar also means a division. So ratio, we're dividing the numerator by the denominator, and we get 97.5 miles when we simplify that. Remember, miles make sense because the question asks us, how far will I travel? We did miles times hours and then divided by hours. So hours divided by hours equals 1, and we're left with miles. Look at it a different way. Now, how long did I travel if I drive 45 miles per hour and I drive 180 miles? Think about what our formula is going to be. This is a distance formula. Distance equals rate times time. But in this case, how long did I travel means that I'm looking for the time. It does give me a rate, 45 miles per hour, and it does give me a distance, 180 miles. So I substitute in what I know. Distance, 180. Rate, 45 over 1. And then I'm going to figure out how to do the time from there. So 180 equals 45 over 1 times time. How do I find this time? Well, I know that 45 is multiplied by this variable. So in order to undo that, I have to do the opposite. I am multiplying. I'm going to divide both sides of my equation by 45. So 45 divided by 45 on this side of the equation equals 1. Now that will leave my variable isolated by itself. So I'm going to have t over here, and then I divide 180 by 45. So let's see what happens. Here I've simplified 45 over 1 to just 45. Now I'm going to divide. So I divide both sides of this equation by 45. 45 divided by 45 is 1. 180 divided by 45 is 4. So my time is 4 hours. And you want to see if that makes sense in terms of our units. This is 180 miles. This is 45 miles per hour. we divided both sides by miles, meaning this is going to be miles divided by miles is going to be eliminated. It's leaving us with hours here. Miles divided by miles over here leaves us with hours. And since it's asking us for time, that makes sense. This is a total cost question. Notice we're talking about money. So let's think a dozen cookies cost $4.50. How much do 5 dozen cookies cost? It's asking us for a total number. What is the formula for the total cost? Total cost equals number of units times price per unit. How much do 5 dozen cost? So that's a total. This will be our variable. We don't know what the total cost is. So then we substitute in 5 dozen. That's the number of units that we have. 5 times $4.50. You might be thinking, well, wait a minute, where does that dozen come in? Because I know dozen is a word that means 12. Where's the 12? In this case, 1 dozen is the unit. So you can think of that as a box. The box happens to contain a dozen cookies. So in this case, we're not going to use the 12 because that represents a unit and the unit is 1. So the total cost equals 5 times $4.50. 5 times $4.50 is $22.50. So that's a very simple one. That you use that all the time. If you're going to buy 3 gallons of gas and that costs $1.50, you know you're going to multiply $1.50 times 3. What's a little bit less self-evident is when we are trying to find another piece of it. And I'm always giving you hints because I forget to add that animation so that flies in. Let's read this problem. The plumber charges $75 an hour. The total bill for labor was $325. How many hours did the plumber work? So here we know the total cost and we know the price per unit. So here's the formula. The total cost is the number of units times price per unit. Our total cost that we substitute in is $325. They're asking us how many hours. In this case, that's the number of units. So we're giving that the variable N. Could have also used H for hours. And then the price per unit, 75. How do I find out what N is? Since these two variables here are multiplied, N and 75, N times 75. I'm going to do the opposite of that to undo that multiplication, which is division. So I'm going to divide both sides by 75. 75 divided by 75 is 1, leaving me with N on this side. And then I divide 325 by 75. And the answer is 4 33/100 equals N. So what is this? 4.33, 4 33/100. We know that 33/100 is the decimal equivalent. Actually, if you did this in your calculator, you would know that this is a repeating number. This 0.333 goes on forever. And that is the decimal equivalent of the fraction 1/3. So the plumber worked 4 1/3 hours. So then these are some samples of GED questions that use formulas. So let's take a look and see if we can figure out what these are asking us. Which formula would we use? A portion of a metal sculpture includes an isosceles triangle. The equal sides measure 15 inches each. What is the perimeter in the triangle in inches if all angles are acute angles? A portion of a metal sculpture includes an isosceles triangle. Well, that's the first thing I'm thinking about. What is an isosceles triangle? If you remember from a geometry unit that you did, an isosceles triangle has two sides that are the same. They're asking us, if I think about this in my head, asking me to say if I can draw something that looks sort of like an isosceles triangle. And it tells me that all of the angles are acute angles. So that means none of them are greater than 90, but also none of them are 90. So that this side are equal, and that 15, and this one is 15. I know that perimeter is side plus side plus side. I have two sides. What would I do for the third side? Well, 15 obviously is not right because the equal sides measure 15 and I have at least two of those. 30 can't be right because 15 plus 15 is 30 and that still hasn't given me anything for this side here. 45, that would be true if this third side was 15, but that would be an equilateral triangle, not an isosceles triangle. 60, that would mean the side would be 30, but how would I know that? The answer is number 5. Not enough information is given. Let's get there. So perimeter equals side plus side plus side. And I said 15 plus 15 plus 15. So clearly when I made this, I did not get to the right answer. And I thought it was an equilateral triangle. And there's my answer. So I actually was tricked when I made this. This would not be the right answer. The right answer is not enough information is given. Let's look at the next one. A cylindrical oil drum is 3 feet across and 5 feet tall. Which expression represents the approximate volume of the drum in cubic feet? So we would have to know what is the volume of the formula for volume. And if we looked it up, we would know volume equals pi times radius squared times height. Now, which one of these is giving us that formula? So I know that pi is 3.14. That's in all of these. Beautiful. And it is telling, it looks like all of them have the height as 5. It won't be this one because it's not height squared. It's radius squared. It won't be this one because this doesn't have anything squared in it. How do I figure out what the radius? That seems to really be the question. What is the radius? So what measurement is this? This is the diameter, and the radius is half the diameter. So the radius should be 1.5 because half of 3 is 1.5 or 1.5, 1 5/10. And which one is that? 3.14 times the radius, which is 1.5 squared, times the height, which is 5. And that will give me the volume. So the radius is 1/2 the diameter. And this equation, volume equals pi 1.5 squared times 5. That would be answer number 1. Here's another problem. Each employee at Walker Industries will receive a cost of living increase and a bonus in January. The personnel department is using the following formula to determine each employee's new annual pay. Okay, so here is a situation where this is not a formula that we have studied, but it is one that the company put together. We approach this problem the same way. We look at the formula, we substitute in what we know, and then we solve for the unknown. So in this formula, N equals C plus 0.04C plus 250, where N equals the new pay and C equals the current pay. So this is going to be what she will make starting in January. This is what she makes currently. So she's getting a 4%. Remember the decimal equivalent right here is the decimal equivalent of 4%, 0.04 times her current pay. So 4% of her current pay plus 250. Well, what is this? That she would be getting a bonus. So she's getting a bonus of $250 plus her current pay plus an increase based on her current pay. So if Sandra's annual pay is currently $19,800, how much will she be paid next year? So remember what we do. Formula, N equals C plus 0.4C plus 250. And I recommend writing it down just this way to start, not looking back over here, but starting on your own work by writing the formula down to make sure that we get the values exactly correct. Then we substitute in our known values. We know we're looking for our new pay. How much will she be paid next year? Then we substitute in what we know. Current pay, $19,800 plus 4% times 19,800 plus 250. And now we do the arithmetic. We solve. Notice that I solved this first and wrote that number down. Again, this is taking it step by step to make sure that I don't make any simple arithmetic mistakes. And then I do this addition problem. And the answer is 20,842. And I wonder, did I write it again with a $? Oh, I did. Sandra's new pay will be $20,842. So this is where we talk about using the unit. Make sure that in your answer you include the unit, which is dollars. Beautiful. And is that on one of our options? It is indeed one of our options. Okay. A parking lot is 41.5 yards wide. What is the width of the parking lot in feet? This is kind of like this is a very simple formula. We know that we're converting yards to feet, and we know that the formula for the number of feet is 3 times the number of yards because there are 3 feet in every yard. So that's our formula. We're going to substitute in feet equals 3 times the yards. We get the number of feet is 3 times 41.5. The feet is 124.5. The parking lot is 124.5 feet wide. So thank you very much. I hope that was helpful.